Welcome to Atiga Tech Academy. Today we'll be looking at how to calculate power in AC circuits. Without wasting much time, let us get started. Please remember to like, share, and subscribe for more content. So to start with, we have power. We have so many power in AC circuits. So we have apparent power, we have real power, and we have reactive power. So these are basically three kind of powers in these are the three kind of powers in AC circuit. So with apparent power, it is represented by S, and it is measured in VA, volts ampere. So in a question, when you see VA, that is apparent power. And with active power, it is represented as P. So it can be said in a question, and it is measured in watts. And it can be said in a question as active power, actual power, useful power, true power, raw power, or just simply power. So when any of these words are used, just know that that is what they are referring to, active power, which is represented in P and measured in watts. And when they say reactive power, it is represented as Q, which is also measured in amperes, volts amperes reactive. So VAR, it is measured in VAR. So when you see a power quantity and they give you the unit as VAR, just know that it is reactive power. So these are formulas that this thing we call the power triangle. This is what we call the power triangle. So with this one, we can use it, this thing, we can use it to produce the whole of these formulas. I wouldn't want to take you through that long process. These are the formulas you need. So realize that the S is the apparent power. They said apparent power is equals to VI. That is the voltage times current. And they said apparent power square here is equals to P square plus Q square. And apparent power here is also equals to real power is equals to the apparent power cos the angle, which is equals to V, which can also be equals to VI cos the angle. And Q reactive power is equals to this or this. And they said cos theta is called the power factor, or PF, which is also equals, you can represent wherever you see cos theta, you can say is PF, or and we can say PF is also equals to the real power divided by the apparent power. So these are the formulas that you will need in your calculation. So you have to know these formulas off head, or also know how to use this whole thing to produce these formulas. So in a separate video, I'll do it on how to use this thing to derive all the formulas. So let's forward. So we have our first problem, which says the electricity company of Ghana installs a substation in the Upper East region worth $5.2 million. This substation supplies 140 VA. So you have to ask yourself, when they say 140 VA, what is it? Realize that this is apparent power S, and 100 VAR, and this is what reactive power Q. What is the real power supplied and the power factor? So we have to first of all find the real power. So finding the real power, we know that, let us write the quantities that they have given to us. We know that the apparent power S here is equals to 140 volts, and the reactive power Q is equals to 100 VAR. So knowing this, we now have to check which formula do we need. They said we should calculate what is the real power. We know that when the formulas I quoted earlier, we had P square, the real power square is equals to the S square minus the Q square, plus the Q square. So here to find P, we simply use that formula. P square is equals to S square minus Q square, because I know S and Q, so I just have to find P. So doing that and making P the subject, I simply find my real power as 97.98 watts. And now I need to now also come and find my power factor. And to find the power factor, I told you that power factor is equals to cos phi. And cos phi, power factor is equals to cos phi, or power factor is equals to P, uh, and P here is equals to S cos power factor. So how do we find the power factor. The power factor can simply just become our P over S, just as the previous formulas I showed you. The P over S, we know the power, which is 97.98. Then we divide it by the S, the apparent power, which was 140. So our power factor now becomes 0.699. So we can just approximate it and say our power factor is equal to 0.699 or 0.7. So, but it's always safe to leave your answer in decimal place, like at least 4 decimal places. So this is how we simply calculate the power factor. Let us take another example and see how it goes. So with our second example, they said an RC circuit having R is equals to 50 ohms, C 80 microfarads. The circuit has an AC supply of 230 volts, 75 Hz. Calculate A, the impedance of the circuit, B, the current flowing, and the power dissipated in the circuit. So first of all, we have to calculate the impedance. How do we calculate the impedance? Z. Calculating impedance, we see that this is an RC circuit, so it becomes, impedance now becomes Z square is equals to R square plus X square, XC square. So doing that, using this formula, we just change the value of R and C. And we know that C, microfarad, the 80 microfarad here can also be equals to 80 times 10 raised to the power minus 6. Micro is 10 raised to the power minus 6. So we simply do that. So doing that, here is 10 raised to the power minus 6. 10 raised to the power minus 6. So doing that, we get our final answer as 26.56 562 ohms. And since we now know the value of XC, we can now just substitute it back into our formula. So 50 square plus 26.5626 ohms. Then we find our impedance as 56.601 ohm. Then we now need to now calculate. They say we should find the impedance. So for B, we need to find the current flowing through and the power dissipated. So since we know the impedance, we can now use the Ohm's law. V is equals to IZ. So finding the current, V is equals to IZ. I here is equals to V over Z. So it's 230 divided by our impedance. Then we get our current as 4.068 amps. And since we now have our current, we now find our power. The power is the current square multiplied by the resistance. So this was our current we found. Then we just multiply it by the resistance to find our total power. So to find the power dissipated now becomes 827.4312 watts. So this is how we simply calculate the power dissipated in the circuit. So it's as simple as that. This side is just formula work. The only challenging thing is knowing how to convert the microfarad back, and you will be good to go. So let's take our last example. Our last example says a generator draws 10 amps when supplied from a 230 volt AC supply. If the power factor is 0.8 lagging, what is the power consumed by the generator? So here they are telling us to calculate the power consumed. So to calculate, and they've given us the current, the current the generator draws. So to calculating the distance, the power, we need to now calculate the impedance. We have to first of all calculate for the impedance. How do we calculate for the impedance? We know that power here is equals to VI cos phi. So VI cos phi, we know I and we know the voltage. So what don't we know here? So we also know from our previous formula that cos phi is known as the power factor. So wherever we see cos phi, we can just put PF there. So and the power factor given to us was 0.8, and since the power factor is 0.8, cos phi here is also 0.8. So we know V, we know I, and we know this. So we simply multiply our 230 by our current 10 by our 0.8 to simply know the current that was consumed by it. Because cos phi here is the power factor. We know voltage, we know current. So here it was just simple as that. So this time is this 230 times 10 times the 0.8. Then we get our final answer. The power consumes as 1840 watt or 1.840 kilo So this is how you simply calculate the power consumed and how to calculate the power in AC circuits. So please, you have to know the formulas well, then know what the right formula to use at what time. Thank you very much for watching, and please remember to like, share and subscribe. Please leave a comment in the comment section. Leave a comment. If you don't understand anything, you can leave a comment so that I'll see how I'll explain it. So in our next videos, I'll be taking you through how to use the diagram to just produce the formulas. I don't think there's something really challenging here. So please take good care of yourself and learn hard. All the best.